Good morning, students. I'm Aisha Nasreen. Today I'm going to take you the class for encoder and decoder. So this is one of our application of a combinational circuit in Unit 2 DPSD syllabus. So what is the operation of encoder? It is a combinational circuit and that converts the binary information in the form of 2 to the power n input lines to n output lines. So this is a combinational circuit which will convert 2 to the power n input lines into n output lines. So where we will use this encoder circuit, it is majorly used to convert a digital signal into an analog signal, as well as it is mainly used in unsupervised algorithms in machine learnings. So these are the major applications. So the binary information is passed in the form of 2 to the power n input lines, and the output line is n bit output line. So this is the encoder logic diagram. Here 2 to the power n inputs are there and n outputs. So there are various types of encoder circuit. Today we are going to see about octal to binary encoder. So what is an operation of octal to binary encoder means? We are going to convert 8 to 3 encoder. It is also called as 8 to 3 encoder. So 2 to the power n input means for representing 8 bits, we will represent the 3 bit. We need 3 bit of data to represent 8 combinations. So 2 to the power 3 is equal to 8 input combinations we need, and the output is 3 bits. So using 3-bit data, we can form 8 combinations of the inputs. So 8 is to 3 encoder, 2 to the power n means 8 inputs and 3 outputs. So D0, D1, D2, D3. So for representing a 3-bit, there are 8 possible combinations from 000 to 111. So from 000 to 111, there are 8 possible combinations. So D0, D1, D2, D3, D4, D5, D6, D7 are the inputs, and ABC is the output. So whenever the D0 is activated, D0 is equal to 1, then the output is 000. Okay, when the second input is 1, then this will appear in the output 0001. Likewise, we will represent this 8-bit data in 3-bit format. So 1, if D0 1 is activated, we obtain 000, and 1 is activated, we obtain 0001. For D2 1 becomes 1, then it represents the third input, so 010. So if D3 1 is activated, it represents the third input. Then if D4 is activated, it represents the fourth input. So likewise, we will represent the 3-bit in 8 different combinations. So now we need to draw the logic diagram. So we all know this is an example of this is one of the application of the combinational circuit, where the combinational circuit, the present state depends upon the present input. It does not have any memory circuit. So the design uses only the gates. So here we will use, see, this is the output. ABC is the output, where we obtain 1 for 4, 5, 6, and 7. We obtain the output for A. Therefore, we need to write A is equal to 4, D4, D5, D6, D7. For B is equal to 1, we obtained using D2, D3, D6, D7. Because for this 000 represents 0, 001 represents 1. So likewise, 0 to 1 representation is here. For D2, we are obtaining 1. So we write is D2. For D3, we are obtaining 1. So D3. For D6, D7, we obtain 1. So we will put as 1. So C is equal to, see, for D1, it is activate, we got 1, and for D3 we got 1, so we put D3. For D5 we got 1, so we put D5, and for D7 we got 1, so we put D7. So ABC combinations where we are getting 1, we need to write those combinations, and then you need to draw the logic diagram. For drawing the logic diagram, So the inputs we need to take D0, D1, D2, D3, D4, D5, D6, D7 are the inputs. And for A, we need to take the inputs as D4, D5, D6, D7. We given to our OR gate and we obtained an A input. Similarly, we will get B and C inputs. So likewise, we need to design a 3 to 8 encoder or octal to binary encoder. The concept is input is 2 to the power n and the output is small letter n. Okay, so in order to get 8 inputs, we need a 3-bit combinations. So the input is 3. So 2 to the power 3 is equal to, we will get 8 possible combinations of input. So if we, for 4:2, for example, if we are going to design a 4:2, we need a 2 to the power 2. Okay, 2 possible combinations of input. So we will get a 4 different types of different combinations. So the opposite of this encoding process is the decoding process. In the decoder, the input is n and the output is 2 to the power n. Okay, so this is enabled using the enable signal. Here we will see the reverse operation 3:8 decoder. For 3:8 decoder, the input is A, B, C and the output is represented as Y0, Y1, Y2, Y3, Y4. The output line whose value is equal to 1 represents the minterms of the binary representation. For example, now we are going to write the expressions for the output terms Y0. So if Y0 is equal to, if we want to activate the Y0, then the ABC should be 0, 0, 0. So we represent it as A bar, B bar, C bar. For representing 1, 0, 0, 1, if the input is 0, 0, 1, then the second output is activated. Y1 is equal to 1. For 0, 0, 1, A bar, B bar, C will become, we will get. So A bar, B bar, C is the output. Likewise, we need to write the minterm expressions for all the 0 to 7 output terms. Similarly, for the return output terms, we need to draw the logic diagram. So the logic diagram is A, B and C, A inverse, B inverse and C inverse. For A, for Y0, we are writing the data A bar, B bar, C bar. For Y1, we are writing the data Y1 is equal to A bar, B bar, C. So it is a 3 input AND gate. We will take A bar, B bar and C as Y1. Likewise, we need to represent for all the 7 terms. So likewise, using it is one type of combinational circuit. Why the encoder and decoder comes under combinational circuit means it does not uses previous data memory. So we are using the present input, we are getting the present output. Okay, there is no memory state. So this is one of the type of combinational circuit. Okay, it is actually where we generally use this type of data means we will use this for converting input signal into output signal, input signal in digital form into output signal in analog form, again analog to digital conversions, in unsupervised learning, in data compression techniques. As a CSE engineers, in data compression techniques, in unsupervised learning algorithms, we will use this encoding and decoding operation. Thank you, students.